Corporate learning programs consume billions of dollars annually, yet they frequently fail to produce the behavioral shifts required to meet business KPIs. This breakdown originates in the content trap, where subject matter experts prioritize the syllabus over solutions. They begin by asking, what textbook content do we need to cover? This forward design pipeline starts with content, moves to lesson planning, and ends with a final exam. This structure often decouples the instructional activities from the actual evaluation criteria. Grant Wiggins and Jay McTeague's backward design model reverses the sequence. It starts with the desired outcome, determines the necessary evidence of mastery, and only then selects the content. Rigorous instructional design functions as the reverse engineering of behavioral evidence. To bridge the gap between abstract goals and concrete performance, we will analyze the 3 stages of this methodology. Educational engineering requires defining the specific destination before considering the vehicle. The first hurdle involves navigating the contradictory demands of corporate stakeholders. Stakeholders often view training as a panacea for systemic organizational failures. They attempt to solve deep operational problems with a single module. Instruction cannot resolve broken software rollouts, lack of employee time, or pure motivational deficits. The instructional designer's power is limited to resolving deficits in knowledge and skills. This defines our learning goals as specific, observable capabilities. Every goal is expressed as an active verb describing what the learner will do. This maps directly to the learning result, the objective proof of that capability. This is the tangible artifact, like a document or a performance, that the student produces. Isolating educational deficits from business noise allows designers to focus exclusively on the variables they can control. We can see this in practice for a case study for an effective presentations course. This chart shows the initial stakeholder demand in the far left column. They want presentations to be inspiring. As an instructional metric, inspiring lacks the specificity needed for design. The second column translates this into a learning goal. The student independently creates and delivers a presentation under specific conditions. This leads to the learning result in the third column. The proof is the generated artifact, an actual presentation deck built or revised by the student. Financial stakeholders add a layer of complexity. As shown here, they aim to reduce costs by replacing external designers and consultants. To meet this economic goal, the student's final artifact must meet professional standards. The result must be a presentation that contains no design errors. This rigorously defined artifact establishes a clear standard of performance that satisfies both educational and business requirements. Step 2 of backward design identifies the acceptable evidence of learning. This occurs before any discussion of lectures or materials. Rather than asking about the format of a final exam, we determine what specific evidence constitutes actual proof of mastery. Understanding is demonstrated when a learner independently applies knowledge within a novel context. The 6 facets of understanding serve as a diagnostic tool for this application, filtering knowledge through cognitive outputs like explanation, interpretation, and application. Standard summative assessments, such as multiple-choice tests, are used to measure lower-tier factual retention. Higher-order skills demand formative assessments. These function as continuous diagnostic loops, including drafts and portfolios, to provide feedback on the apply and interpret notes. In this model, the assessment provides the specific architectural blueprint for the required cognitive output. Step 3, planning learning activities, occurs only after the evidence of mastery is defined. Defaulting to content first creates cognitive overload. Dumping excessive data onto learners creates a bottleneck that prevents retention. The concentric circles of knowledge model filters this data. If information does not directly enable the student to produce the final artifact, it is moved to the outer rings as secondary context or removed. This process isolates the critical core. Using frameworks like Where2, this core content is integrated into active mechanisms like hooks, practice sessions, and reflection points. Content serves as the temporary scaffolding used to build a learner's capability. Once that capability is established, the scaffolding is no longer required. The final verification of a curriculum is its structural symmetry. This blueprint maps the course logic. We begin verification at the end, with educational results. Through a reconstruction test, we trace backward, Confirming artifacts are explained by selected content and skills. If this reconstructs the original learning goal, the course achieves internal structural alignment. Improving instructional outcomes requires moving past the question, "What should I teach?" The relevant question is, what must the learner prove, and what scaffolding is required to get them there? By starting at the end, we ensure that every hour of instruction serves the specific evidence required for mastery.